Howdy everyone, this is the first video from the Karamba side of this course. In this first video, we're going to keep it really simple. We're just going to do a beam structure with two connections, or as we'll call them, supports. This video is going to cover one of the most simple possible structures that you can create in Karamba. We are going to add a little bit of complexity to it just by adding two load points. We're going to go through the entire workflow by creating the geometry, creating the beam, supports, load, and then analyzing all of those results and actually showing them visually as well with some different colors to show different areas being stressed. So this is the type of beam that we'll be creating with one support on either side. So these are some of the components that we'll be using. We'll go into detail on all of these and start to understand why each of these components feed into the other and how it creates the final analysis. Our expected results includes showing the beam almost bent because it's under load, and we'll also show the beam being colored with the areas of most stress being colored in red and areas of low stress being colored about blue to purple. We're going to start by opening up a fresh Rhino file, and once your Rhino is open, just go ahead and type in units. This will pull up this menu, and you want to make sure that the model units are in feet. Then we want to open up Grasshopper just by typing in Grasshopper, and so you can see that it opens up a fresh Grasshopper file for me. I'm going to go ahead and toggle on the grid just by pressing F7. This is just going to make it a little bit easier to draw out all of our components on our viewport. In the Rhino window, I'm just going to type in point. And so you can see that I can start placing a point here. I'm going to click on this intersection right here. And then I'm going to press space or enter to bring back the last command that I used. So this just allows me to place multiple points. So I'm going to place another one right next to it. I'm going to place two more. So these points are going to represent our supports and loads. These 2 points on the outside will act as our supports, and these two on the inside will act as our loads. Now we're going to connect all of these points together with lines, so I'm just going to type in line. Just connecting each of them together. You should have 3 lines here. After that, our beam is fully set up, and our support and load points are also set up here. Now we can start placing our Grasshopper components. So what we're going to do is we're going to open up Grasshopper and then make sure we're on the Karamba 3D tab. After that, you can go up here and click on Assemble Model. So this will let you drag a node and drop it into your canvas. Another trick that I'll be using here is just by double clicking on the canvas, I can start typing in the component name, and then you can just click here and drop it in. Selecting and deleting works the same way as it would on your regular Rhino viewport. So this component allows us to bring in all of our different curves, all of our different loads, supports, and whatnot. In Rhino, these lines are called curves. So to bring them into Grasshopper, we just need to type in curve. And then we can right click on curve and set multiple curves. Then we can select our 3 curves here. Now let's see what happens when we try to connect the curves into our element input. You can see that it doesn't work. The reason is Karamba can't read these individual curves as a beam, so we need to tell it that those curves should act as one beam. I'm going to press Ctrl on my keyboard and I'm going to drag that same path just to get rid of it. Then I'm going to go into Model and create linear element. I'm going to drop that in right here. Just a quick note, you can actually see all of the different component names on the top right here. Yours might not show it, but that's a good way to see exactly what components that I'm using. I'm going to take my curves and I'm going to drag it into the line input. And then I'm going to take my element output and drag it into the element input. Now you can see that when I press on my curves, this whole line is highlighted, showing that it is in fact taking those into account. So what this component here does is that it just takes all of those different curves and it says this is one beam and Karamba should consider it as such. Next, let's bring in the support points. So I'm just going to click on the canvas and I'm going to start typing in point. Then I'm going to right click it and set multiple points. So these outer 2 points are our supports. After I'm done selecting them, I can just press enter. And now you can see that those are highlighted, showing that it's taking those points into consideration. Then I'm going to type in support, and it's going to be the first one over here, support Karamba 3D. Then I'm going to take my point output and drag it into this first input of the support component. One thing to note on this component is that these 6 buttons on the bottom are your degrees of freedom. Because we don't want these supports to be able to move, let's go ahead and constrain all of them by locking them down. you can just click on each of these buttons. It'll fill the circles to indicate that those are now locked. I'm going to take the support output and drag it into the support input of the assemble model component. Next, I want to set my load points. So I'm going to do something similar. I'm just going to type in point. I'm going to select the middle two here. I'm going to press enter. So you can see that those two are now selected. I'm going to add in the loads component now. So I'm just going to type in loads, and it's this third one right here. Before connecting these two, I'm going to click on the type of load, and I'm going to change it to point load. This is because we want our loads to be created from our points. I'm going to drag the point output into the fourth input of the loads component. And now we need to define a vector and a magnitude to each of these points. This means that we're giving these points a load direction, so we want these to be facing downward. And then we want to set how large the force on each of these points is. To define our direction of these loads, I'm going to double click on the canvas and I'm going to type in unit Z. Then I'm going to create my magnitude. I'm going to start typing in 0.01 is less than 10. So what this does is it gives me a number slider that increments in these small quantities all the way up till 10. I'm just going to go ahead and keep it on 2 for now, or around 2. Because we want the force to be downwards, we're going to add a negative component. And we're going to take the output from the number slider into the input of the negative component. Now we need to multiply these two together. So we're just going to type in multiplication, and we're going to connect both of those to the input of multiplication. Now you can see that when we hover over the output, we have a negative magnitude in the Z direction. We're going to take that output and drag it into the force input. A useful trick that you might need to use when you place Grasshopper components is by hovering over the inputs or the outputs. It'll tell you exactly what that input needs. Now we're going to take our load output and drag it into our load input. So just to recap before going further, let's go through what each of these components do. The create linear element component just accepts all of our curves and considers it as one beam. The support component just allows us to set our two different supports that we're using on this beam. And the loads component allows us to set our two different load points on this beam. This section here just allows us to set our force direction and the magnitude of that force. Now we want to see the results of this visually, and we need to start computing the analysis. To do that, let's convert this into a model. So I'm just going to double click and type in model. Then I'm going to take the model output and drag it into the model input. And then to start computing and analyzing this, we're going to start typing in analyze, and the model output goes into the model input of the analyze component. If you want to actually show this beam being deformed, I'm going to start typing in model view. Then the model output again goes into the model input. And so you can see that the beam is now showing up as deformed. Our load points are showing up correctly in the correct direction. But you can see that this is quite large. So we're going to go back to our magnitude slider, and we're going to bring this value down. Here on the support points, you can actually see the degrees of freedom being constrained. If I go to the support component, we can actually toggle on and off these degrees of freedom. Now we can actually change how this looks visually. So if we start dragging this down, we can see that it changes quite a bit. After that, let's represent our beam stresses visually. So I'm just going to start typing in beam view. It's this component right here. Then we're going to take our model output and drag it into the model input of beam view. You can see that adds a pipe around the beam here. And then we're going to click on display, and we're going to change this to axial stress. So now you can see that the areas of high stress are colored in red, and the areas of low stress are colored in this bluish purple. So one more time, let's just recap everything that we did. We added our loads, we created a beam, then we added our support, and then we set our load points, and we also set our magnitude and direction here. Then we converted that into a model that Karamba could analyze, and then we represented that model visually here. Now here's a quick challenge that you can try. Using the same beam component, let's vary our load points. We want one force coming from this direction and the other force coming from this direction. So we want to deform the beam in kind of this shape. Go ahead and try it out on your Grasshopper and Rhino file, and pause this video because I'll be showing the solution to it in just a second. So this is the solution to the problem. What we did is we duplicated that same load section. After that, we reset these point inputs to just one point. So each of our two load points just get its own section. You can see that only one point is selected for each of these. Then we changed our vector direction to unit Y, and we also got rid of the negative component on one of our loads. After that, I pressed Shift to add multiple inputs to this assemble model and just connected it like so. In the next video, we're going to talk about cantilever beams and start to add a little bit more complexity.